piece of wire, 20 centimeters long, is to be cut into two pieces. One piece will be bent into a square, and the other will be bent into an equilateral triangle. How should the wire be cut to enclose a minimum total area? Okay, so here's our wire, 20 centimeters long. And we're going to cut, first we're going to cut it into two pieces with not necessarily the same length. So if one of those pieces is x units long, what do we call the other one? We could say y, but then we're bringing in two variables when we don't really need to. The cleaner way to do this is to say one of the pieces is x, the other one is 20 minus x. Okay, so when we have the pieces, we take the first one and we bend it into a square, and we take the second piece and bend it into an equilateral triangle. So how big is each of those going to be? If we take x worth of wire and bend it like this, we're using a quarter of it on each side, so each of these sides should be x by 4, etc. And if you take 20 minus x and bend it into 3 equal pieces, then you get 20 minus x by 3, 20 minus x by 3, and one more time. Okay, this is getting steadily messier and I'm worried about it, but we should be able to manage. The thing we're supposed to minimize is the area. So what are the areas of these things? For the square, the area is the side length squared. So it's x by 4 over x by 4, which makes x squared by 16. There's part of our area. This other section is a triangle, so its area is 1/2 base times height. So 1/2. The base is 20 minus x over 3. And the height is, we don't have it. But we can get it, because we know trig. Here's the height, which we need to find. Equilateral triangles have 3 equal angles, and they're all 60 degrees, always. So looking at this triangle, this is its hypotenuse, 20 minus x by 3, and this is its opposite side. So opposite and hypotenuse, the sine function should be able to help us here. We can say sine 60 equals the opposite side. I'm going to write out the word height because if I put h, you might think hypotenuse, and that's not the case. Sine is the opposite side over the hypotenuse, which is 20 minus x over 3. Okay, sine 60 is root 3 over 2. Over 20 minus x over 3. And now if we multiply both sides by 20 minus x over 3, we get that the height is root 3 over 2 times 20 minus x over 3. When I write that in here, I'm going to multiply the 2 and the 3 together. You're going to see a 6 in the denominator. Other than that, I won't change anything. Root 3, 20 minus x all over 6. Okay, so the triangle is 1/2 base, there it is, times the height, just found it. And if we clean that up, I don't think it's going to get a lot better, but what can we do here? We've got, in the numerator we have root 3, and then we have 20 minus x twice. And in the denominator, we have 2 times 3 is 6, times 6 again is 36. So that, I believe, is the complete area for the triangle. And those two areas together are the thing that we must minimize. All right, so that said, let's clear some space and get this area put together, and then we'll see if it's something we can differentiate. The total area of the square and the triangle combined is just those two things added together. So x squared by 16 plus root 3 over 36, 20 minus x all squared. So if we do the derivative, I kind of wish I'd written 1/16 x squared. I'll probably change that on the fly. Our derivative is going to be dA dx. 2 times 1/16 gives 1/8 x to the 1. And then we get, first we do the power rule. So 2 times this is, it's 2 root 3 over 36, which becomes root 3 over 18, times 20 minus x to the 1 now, times the derivative of the inside, which is negative 1. So if we clean that up, there isn't a lot of cleanup to be done, really. We get dA dx equals 1/8 x minus root 3 over 18 times 20 minus x, and we want all that to equal 0. Okay, clearing some more space. If all that equals 0, what have we got? I'm just going to recopy it first. This minus root 3 over 18 distributes to both things inside the brackets. So if we do that, we get root 3 times 20 over 18. That's a little bit reducible, and I'll get to that in a minute. And then we get minus root 3 over 18 times minus x, which is plus root 3 over 18x. And all that equals 0. We could try to get a common denominator for all this. I'm thinking we should probably just go to decimal form because these numbers are going to get pretty ratty anyway. This is a non-terminating decimal, so it's not like we can keep this nice. Let's just accept our fate and go to decimal form. 1/8 is 0.125. X minus, out comes the calculator, root 3 times 20 divided by 18 gives 1.925. And then we have root 3 divided by 18, which is 0.096. Yeah, all the others are to the nearest thousandth, so I'll do that here as well. 0.096x, and all that together must equal 0. These are like terms because they both contain x, so we can add those up. 0.125 plus 0.096 is 0.221. So 0.221x minus 1.925 equals 0. Take the 1.925 to the right. And divide both sides by 0.221, and we get 8.71. So we should use 8.71 centimeters of our wire to produce the square. And 20 minus 8.71 is 11.29 centimeters to make the triangle.